Hi everyone, this is lesson 321, constant ratios in right triangles. In this lesson, this actually takes us to another part of the world, uh, looking closer at the Leaning Tower of Pisa. All right, so in this problem that we're looking at, we're really going to start this problem, and I'll tell you now, we won't be able to solve this problem quite yet, but we will need to learn a little bit more before we can solve it fully. But unless you already have some prior knowledge, you might be able to solve this on your own. So a little bit of background. This is the Leaning Tower in the city of Pisa. And this is what it actually looks like. So it is leaning, and some feel like maybe it's in danger of falling over. Now, when they first built it, it was not leaning. The intention was for it to be standing straight up. But over time, it started to fall. So you can imagine maybe the ground below it became too soft, especially maybe on one side, and then it started to lean over. So the question really is it gonna ever fall over? And that's what we're looking at here. So if we look at this angle, we're going to try to figure out what's the measurement of that angle, and what angle would we need to know, or what angle would it have to be for us to tell, like, oh, this is in danger of falling. All right, so initially when it was built, it was 90 degrees, and over time it's become a little bit smaller. So if the tower was this leaning over this much, you might say, oh my God, it's going to fall very soon. So we're going to look at a little bit more measurements in order to kind of figure out how to do this. All right, so visually, so I wanted to show you a picture of it, an actual photo of it. The book has a drawing of kind of the same thing, so you can kind of see they look very similar. And so there's a little bit more context to the Leaning Tower. All right, so this was built in the 1100s, and people go visit it quite often because of how it looks and the fact that it is slanted. All right, so the tower has slowly tilted south and has increasingly been at risk of falling over. All right, so it is feared that if the angle of slant ever falls below 83 degrees, so under 83 degrees, so 82, 81, so if it ever gets below 83 degrees, the tower will collapse, all right, which obviously they don't want it to collapse. So some additional information in the diagram that's given to us is if from this point, point A, we drop, let's say, a weight that goes straight down, that would be a distance of 50 meters. Also, that weight would fall 5 meters away from the base of the building. So there's a couple measurements we have, and people have actually, this is kind of what they've done to kind of figure out some angle measurements, is if they drop something straight down, it falls 50 meters, and it's 5 meters away from the base. So we know these measurements. What we want to figure out is what's the angle of slant. So this angle that's in here, which would be the same thing as if I say this angle here. So this angle is the same as this angle. So if you notice, we've actually created this triangle, right? This right triangle. So what can we calculate with the given information? So I'll tell you a couple things. One, this has come up before on a similar problem where we deal with right triangles. If we have a right triangle and we know two of the sides, then we could figure out the missing side. Now, if I figure out the missing side, the question is, does that help? Does it help us figure out that whether this is going to be below 83 degrees. So the question is, does that matter to us? Is there anything we could do to figure out the angle of slant, right? How can we figure out this angle down here? So one thing that most people forget is that when you do have a line, any kind of line, what's the one thing that we always talk about when we talk about lines, right? Sometimes we'll talk about the equation of a line. And sometimes in the equation of a line, we talk about the formula y equals mx plus b. And so what do these things represent? So usually we talk about slope, right? So what's the slope of the line, right? And so if you don't remember, slope of a line is rise and run, rise over run. So we actually have those measurements, right? So if I ask what can we calculate with the given information, we could calculate the distance of the side of the building, but more importantly, we could calculate the slope. All right. So, and just as a reminder, that would be the rise over the run. So for us, what's the rise and run of this shape? Well, the rise would be 50 meters. So that would be 50. And the run, in this case, would be 5 meters. All right. So that means we have a slope, the slope of that building. Right? So this actually reduces. So this would be, I guess we could say this is 10 over 1. Right? So that's something we figure out. Now the question is, does that help us figure out whether this building is going to collapse or not? So how does this number relate to maybe the slant, the angle of slant? And that's what we're going to have to look at a little bit more. All right, so this is our initial problem. Our goal is to figure out the answer to this problem, which we might not get to for a couple of lessons. So we have a lot more to learn, and so that's kind of the beginning of that. And so some just reminder of slope information that you need to know, because a lot of times now that we're starting to talk about slope, we need maybe a little bit of reminder of what slope is. And so sometimes we refer to slope as slant, lean of a line. How much is it slanted? How much does it lean? It can be represented or calculated in different ways. So you might have seen a slope in different types of problems. The most common that you should be familiar with at this point is y equals mx plus b. And so that's kind of where we've seen it. Below, I have different ways of representing it. So we usually write slope with the letter m in our equation, like we saw here. And some of us, maybe we remember that slope is always rise over run. And that is also can be viewed as this formula to calculate the slope. And so you might recognize this one, y2 minus y1, right? Which y values are the values that go up and down. So that would be the rise. And then x2 minus x1, that'll tell you the movement from left to right, which is our run. So this represents rise, this represents run. So what might be new on this for this lesson is they're going to be using or introducing this notation for you. So you'll see this little triangle and a y and a triangle and an x. It's actually not called triangle y, but it's called delta y. So in this case, I'll even write that delta y and delta x, right? So which means the change in y or the change in x. Right? So all these terms kind of mean the same thing. So if you see this little symbol, I would say delta y. If I see the symbol at the bottom, I would say delta x. Right? So that's kind of how you read it. It's called delta because this little triangle is a Greek letter called delta. Right? So that's one of the Greek letters we'll be using moving forward. All right, so that'll come in a little bit later when we start solving some problems. All right, so in this first problem, we're looking at this line, and this question is having us look at a specific slope triangle that's given to us. So if you don't remember slope triangles are triangles that you draw on a line that happen to be right triangles. So it's really just us drawing in the rise and the run, right? So that's our slope, the rise and the run of this line. And so this question is asking us, can we draw more slope triangles on this same line that do not have the same measurements as this original one? And so what I mean by that is, let's see if we could draw in, instead of having a triangle with a rise of 1, maybe I want a triangle that has a rise of 2. And so let's see what that might look like. All right, so this is what I'm going to do. I'm going to, let's see, 3, 6, 7, 8, 9. So I'm going to draw it right here. So here I have a rise of 2. You can see that it has a height of 2 here. And that means, what's going to be my run? So if I draw a line that goes straight across, right? If I draw a line that goes straight across, then that means if I count those boxes, that would be 3, 6, 9, 10. All right, so this is us creating a slope triangle that has a rise of 2 and a run of 10. All right, so those would be the measurements. So then the question is, well, has that angle changed? So this angle in here, so this one is 11 degrees. What's the measurement of this one? Is it still the same? So if you're not sure about that, so let me see if I could color that in. And so if I take this, let me just take this portion and I slide it down, you should notice that it fits perfectly inside. All right, so that angle is actually the same angle measurement. So let me write that in. So this is also 11 degrees. All right. So then, can I draw other triangles? And so let's do at least one more on this one. And I'll even draw it, let's say, above it. It's okay if we draw it above as well. And let me use a different color. So let's do a rise of 3 on this one. And I'll just go here. So let's say I have a rise of 3. And what would be the run on this one? So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so we have, this is a run of 15, and this has a rise of 3. All right, so what are the slopes of all these? So the slope, we said rise and run of the first one was 1. Rise is 1 over 5. And then this one's 2 over 10. All right, so this is the slope of this one was 2 over 10. But if we reduce that, you'll notice it's also 1 over 5. And this one, the slope is rise is 3 over 15, which you'll notice is also 1 over 5. So they all reduce to the same 1 over 5. All right, so a couple of things we want to keep track of, and we're going to do this a few times, is what's the slope angle and what's the slope ratio. All right, so in this case, the slope angle on all of these is 11 degrees. And the slope ratio is just another word for fraction. So the fraction for all these was going to be 1 over 5. Okay, so moving forward with this information, what happens if we use the same line with a slope angle of 11 degrees? So imagine that same line. What if the slope triangle had uh, delta y equal to 6? Delta y is the same as our rise. And what would be the delta x? So if it has a rise of 6, what would be the run? All right, so let's look at this example. And that's the first question. There's actually two we're going to look at. And so I've drawn out both of those for us. All right, so the first one is I'm going to focus on the left side here. Is here I have a slope triangle. I've already labeled it 11 degrees. So this is the same as the problem above. But in this case, they already told us we have a rise of 6, a delta y of 6, or a change in y is equal to 6. But I want to know what delta x is. Well, if I think about it, all the slope ratios, the slope ratio of all the 11-degree slope triangles from the previous problem all had the same slope, and that slope was 1/5. Now, if this slope triangle is the same as all the others, that means this one should have the same slope. But what I do notice is the measurements here are a little bit different and missing. So, but if I take this the slope ratio of this triangle, and I include it in my proportion, so let's include that. So this is going to be, rise is going to be 6, and the run we don't know, so I'm going to put delta x. That'll be our variable that we're solving for. So now we have a proportion that we could solve. So if we use our skills from before, cross multiply and solve, then we should end up with a solution to this. So in this case, delta x times 1 is delta x, and 5 times 6 is 30. All right, so in that case, again, if you're still not sure how we're getting that, that's because we are cross multiplying to get the solution. All right, so that means, let me highlight the answer. All right, delta x equals to 30. So we figured out the missing side of a triangle. That's awesome, because all we had was one side and an angle. So this is huge. We had two pieces of information, one angle and one side, and we figured out the missing side. And the only thing we needed to know was, well, what are all the other ratios equal to with the 11 degrees? All right, so let's try this again. Second part to this, it's not described in the words, but I'm just going to tell you. So the delta x, let's assume the delta x in this case is, what if I tell you it's 40? Then what's delta y? All right, so what can we do to figure out what delta y is? So if you want to try to do this on your own, you probably want to pause it first, try it, or else I'm going to go over the answer. So to start this, I'm going to set up a proportion. So I'm going to have a fraction equal to another fraction. And so this is an 11 degrees. So I'm thinking, what are all the other 11 degrees slope ratios equal to? And like I have above, slope angle is 11 degrees. That means the slope ratio is 1/5. All right, so then I'm going to fill in 1/5. And what's the slope of this triangle? Well, this specific triangle, I'm looking at this specific triangle, I have some different measurements. So I'm going to use those. So I don't know what delta y is, so I'm going to put delta y. But I do know what delta x is, and that's going to be 40. Which means when I solve this, if we cross multiply, this is going to be 5 times delta y is equal to 40, which means if you divide both sides by 5, you will discover that delta y is equal to 8. All right, so that would be our solution there. All right, so we figured out our rise if we were given our run, or we figured out the run if we're given our rise. All right, so moving forward, so let's look at some other angles. So it's nice that we have an 11 degree, but it's probably not every line is going to have an 11 degree slope angle. So we're going to look at a few. And so here's the first one. So it says, let's graph y equals 2/5 x, right? 2 over 5 x. So all we're given here is an equation to graph, and we have a graph as well to graph this. Our goal is to figure out what's the slope angle and what's the slope ratio. Well, if you remember your formula for y equals mx plus b, this looks very similar. The only thing that's missing is that plus b part, which means this must be a plus 0. So that y-intercept is going to be at 0. So I would start this process by plotting that first point at 0. And then the slope of this line is going to be in front of the x. So it's actually given to us in front of the x. So 2 over 5. So I'm actually going to write that in already in the slope ratio. This is going to be 2 over 5. So all I need to figure out is the slope angle on this one. So let's graph this. So if the rise and run is given to us, then we could just use it. So I'm going to go up 2 over 5, and then, 5, and then up 2 over 5, and then up 2 over 5. And you repeat that process, and you should have a line that goes through. So we should have a line. So let's do that. So up 2 over 5, that's a point there. Up 2 over 5, that's a point there. All right, so we should have, and you can keep going on until you have run out of space. And you should have a line. You should have a line that goes through all these. All right, something like that. So, and what we want to do is figure out the measurement of this angle. All right, so what's the slope angle for this one? Well, we don't have the tools necessary in front of us. If we were in the classroom, I would give you a protractor to measure this, but so since we're not, I'm just going to kind of tell you what this is. If I was measuring this, I would be using a protractor, which gives us all the measurements that we'd be looking for. And as you remember, a straight line is 180 degrees. So let me draw it this way. So 180 degrees. So the question is, how many degrees is this? So I'm going to tell you what it is. So if I draw in a slope triangle, right, if I draw in a slope triangle, this angle here is going to be 22 degrees. All right, so this is going to be 22 degrees. What you should notice kind of relates to the previous problem. The previous one had 11 degrees and the slope ratio was 1/5. But this one is 22 degrees, right? 11 degrees, now it's 22 degrees, twice as big, and this is 1/5, and now it's, 1/5 now became 2/5, twice as big. So you could see as the angle gets bigger, our fraction is going to get bigger as well. The slope ratio is going to get bigger. And so these are approximations. They're not exact, but they're pretty close. All right, and then we have a couple more we're gonna do. This is, they started off a line with us. They actually want us to draw an angle that measures 18 degrees, which again is difficult to do if you don't have the tools uh, to make it exact. But we're gonna do our best on this one. So what I'm looking for is, I'm missing a point. I have Q, P, and then I need another line here. So somehow I need another letter R. So our goal is to draw something like this. And this angle here needs to be 18 degrees. All right, so that's kind of our goal here. And so this is gonna be, let me draw that in for us. And let me write this. So slope angle, we already know the slope angle is 18 degrees. And our slope ratio, and I'm just going to tell you what the ratio is now, so to kind of help us draw this. This is going to end up being approximately 1/3. Right? So if you're drawing this one out, that's probably going to be the most accurate line that you could draw. So I'm going to go up 1/3. 1/3, and let's see. All right, and oops. All right, so up 1/3. 1/3. All right, so as we draw this out, you're going to end up with a line something like this. So this is going to be, if I actually draw in a slope triangle, this is going to be 18 degrees in here. All right, which is a little bit less than the 22 degrees. 18 is less than 22. And that 1/3 is going to be less than 2/5. All right, and then the last one is going to be another equation to graph. In this case, we do have a b value here. So I'm going to start with the y-intercept, which is at 4, which is going to be up here. And the slope, the question is, what's the slope here? I don't see a number in front of x, but in front of x, there's going to be an invisible number, and that invisible number is 1. So really, this is the same thing as y equals 1x plus 4. All right, so the slope in this case is going to be 1. So now technically I already know the slope, which is going to be 1, and I'll say it's 1/1 just to keep it as a fraction. The question is, what's the slope angle? All right, so let's draw that. So I'm going to go up 1/1, up 1/1, rise over run, and this is going to give us a straight line like this. And what if we draw in a slope triangle here? Question is, what's the measurement of that angle? So if this is 4 and this is 4, which reduces to 1/1, what's the measurement of this angle? Well, if you think about it, if this was a 90-degree angle, right? If this was 90 degrees and we cut that in half, right? We've literally cut that 90-degree angle in half. Well, what's half of 90 degrees? All right, so this is going to be 45 degrees. 45 degrees. All right, so at this point, we're building our collection of information. Slope angle and slope ratio. All right, so that's the information that I need you to have from this lesson. All right, so make sure you definitely have that stuff copied down. It's going to come in handy when we talk about the next lesson.